Hey everybody, and welcome back. Today we are going to do a review lesson on adding and subtracting fractions. So first thing I want to talk about is decomposing fractions. So this is a big word, but it just means breaking up fractions into smaller fractions. So if you get a fraction it says to decompose it, there are lots of different ways that could be done. So for example, we have 6/7. That could be decomposed into 3/7 plus 3/7, or 5/7 and 1/7 would make 6/7, or we could have 6 groups of 1/7 would equal 6/7. Those are all three different ways to decompose a fraction. So if I was given this fraction here to you, and it's 5/8, there's lots of different ways we could decompose 5/8. We could do that with 4/8 plus 1/8, or we could do 5 groups of 1/8, 2, 3, 4, 5, or lots of other options. These are just two options for decomposing 5/8. Okay, something to remember: when you add or subtract fractions with like denominators, so denominators that are the same, all you have to do is add or subtract the numerators. So if I have 2/5 plus 2/5, my answer would be 4/5. I'm not changing the amount of parts, just the amount of parts shaded or used. Same with subtraction. 7/9 take away 9/9, I'd just be subtracting 7 minus 3, which would be 4/9. Here I have 6/12 plus 7/12. I know 6 plus 6 would give me 12, so 6 plus 7 would give me 13/12. And this would give me something called an improper fraction, which we will talk about in a little bit. As a review, I know many of you already know. Next we have 13/4 minus 5/4. Yes, the number is bigger on the top, but we can still subtract easily because the denominators are the same. So all we have to do is subtract 13 minus 5, which would give us 8/4. All right, so like I was talking about before, we've got two different kinds of fractions to think about when we get an answer and the numerator is greater than the denominator. We call this an improper fraction. This can be your answer a lot of the time, and it might be on a lot of your options on tests and quizzes. However, when the numerator is greater than the denominator, we know we have more than one whole. How do we know this? Well, we know we have something called a mixed number, something that has a whole number and a fraction. If you look at the denominator to know, that will tell you what is equal to one whole. So, for example, in our example here in the number 7/4, we know that if 4/4 equals one whole, then 7/4 take away that one whole of 4/4, we'd be left with 3/4. So 7/4 is equal to one whole and 3/4. If we can pull out a whole out of our fraction, our original fraction, and still be left with a fraction left over of 3/4, we have a mixed number. Sometimes it'll come out evenly and we'll just have a whole or two wholes or more. Another thing I want to talk to you guys about as a review today is when we're adding tenths and hundredths. Okay, so that means we have a fraction like this, or we have 30 hundredths. And a little picture I made for you, this was a hundreds grid, so if you were going to count each of these squares, you'd count 100 squares in all, and there would be 10 squares in one row or one column or row. So I'm going to shade in 30 individual hundredths, so 30 individual squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I just shaded in 30 hundredths. Okay, now you'll note I'm now going to look at 3/10. And if I'm shading 3/10, that means I'm shading 3 groups of 10. So if these were divided into hundredths again, then I would be shading another 30 hundredths. I'd be shading one group 1 out of 10, 2 out of 10, 3 out of 10. Okay, so this is a square that's divided into 10 slots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you'll notice the same amount is shaded in 3/10 as in 30 hundredths. These numbers are actually equivalent to each other because they are the same amount shaded. We didn't change the amount of parts, or we changed the amount of parts, we just didn't change the amount that was shaded. So if I come down here and I'm looking at a question that's asking me to add 3/10 plus 30 hundredths, these have unlike denominators. However, if 30 hundredths is equivalent to 3/10, if these are the same amount, then all I need to do is change this fraction to be equal to this fraction when it comes to the denominators. I want my denominators to match. So I want them both to be hundredths. So if I change this to hundredths, 3/10 would be equal to 30 out of 100. So that means anytime you see a fraction that has 10 on the bottom and you're adding a hundredth, all you have to do is add those 2 little zeros there. It's a great trick. So now I've got 30 hundredths plus another 30 hundredths, 60 hundredths in all. And some of you already know another answer for that would be 6/10. Because 60 hundredths would be the same as having 6/10. Look, I can even hide both zeros, one on the top and one on the bottom. And I can see if I took away those 2 zeros, it would be the same fraction as 6/10. All right, so let's look at some more examples. 4/10 plus 36 hundredths. So using my zero trick here, I want my denominators to be the same. I want them both to be 100 so that I can add what's on top. Whatever you do to the bottom, you also add a 0 to the top there. So 40 hundredths plus 36 hundredths would get me to 76 hundredths in all. And for this, they don't both have zeros at the top, so it's not like it would be equal to 70/10 because we have a 76 here. Okay, so this would be the only answer. Next we have 5/10 plus 66 hundredths. Again, I can do my little zero trick so that the denominators are the same. And now I can easily add 50 hundredths plus 66 hundredths. I know 5 plus 6 equals 11. And 0 plus 6 equals 6. So it would be 116 over 100, which would give me an improper fraction. If you wanted to go further and see if you could find what is the mixed number version of this fraction, you can go ahead and do that. Next, we have 43 hundredths plus 2/10. Again, even though it's on the other side, I can still do my same trick here. 43 plus 20, 63 hundredths. Okay, so now we have one of those boxes where we're trying to get from 6/10 to 47 hundredths. There's a missing number in the middle, but we have hundredths on the bottom here and in our denominator here, and tenths in our denominator here. So we want the denominators to be the same so that we can reach an accurate answer. So I'm just going to change this to 60 hundredths. And I just realized we can't add anything to get to 47 hundredths. So I'm just going to change up this question. So now it would be 60 hundredths plus what gets you to 470 hundredths. So you can count up by tens in your mind. You can subtract 470 minus 60, which is what I'm going to do. I know that 470 minus 60, 470 minus 70 would be 400. So 470 minus 60 would be 410 hundredths. And last, we're trying to, again, get from 7/10 to 240 hundredths. I'm simplifying this a little bit by adding that 0. You would not change this. You're only trying to find this answer. So I'm trying to see how to get from 7/10 to 240 hundredths. Well, I can do that by making my denominators the same. 70 hundredths plus what gets me to 240 hundredths? Well, I can count up by tens. Let's see, 70 plus what will get me to 240? Let's count by tens. It's the other strategy we could do. 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230, 240. So I had one group of 10 and then more groups of 10. So I had 170 over 100. That makes sense because 7 plus 7 equals 14, which would add another 100 to the hundreds space. Okay. I know that was a lot, but I know you can also do it, and I will be available for office hours to help you. Have a great Tuesday.